day and welcome back to the lab. And today here on the bench we have MFJ automatic IntelliTuner, which is 1.5k watt tuner, which is not working. So let's go right to the bench and let's see what we can do. Look here, and this is a massive tuner. So, and its part number is MFJ 998RT. So, and the system was connected at the antenna of the old man, and he was not operating. He was not able to operate his system since his radio was showing high SWR. And you know, I already guess what. So we all know that this kind of antenna tuner is normally connected to the feed point of an antenna. And therefore we need to get somehow the needed voltage, the power, the 12 volt DC to the tuner itself. And since it is connected to the feed point of an antenna, there is very often no 12 volt DC to supply the tuner. And therefore those tuners get fed by this MFJ bias T. And yeah, you know, I think we have again here a problem with the bias T, but let's check it out and let's see if my assumption is right or not. Okay, so first of all, the setup is very simple to see and understand if our tuner is working or not. So for the first test, I have simply connected here my test radio, and it is set to 10 watt output power, so that is totally fine. And of course it is set to FM because I need a carrier to test it. Then we have set here the input and the output, so the output is simply connected here to my LP 500. And for the first test we have not connected our power supply. So under this condition it should simply feed our signal through without any problems, and we should see our 10 watt here, which I've set the radio to, without any problems. So let's do that first. So you can see the microphone. Now let me press PTT. Yes, and you see that is working. So it is a little bit funny that it is reading 1.3, but that is because very often the output impedance is not that good, but 1.3 is still a good SWR, so no problem so far. Now the next step is that I connect my power supply to our unit here. Okay, so I've already connected here our connector, but my power supply is not switched in. So let me do that, and okay. So I do not know if you heard the click, but we see that our MFJ is drawing 186 milliamps, which is in general a good sign, because we know something is working inside. So now, of course, we have a very good dummy load connected to our LP 500. So the load is exactly 50 ohm, and that means that normally we should see with our MFJ connected inline, we should still see a good SWR, and that is fine. So you see 10.4 watt output power, and our antenna is just fine, no problems. And I've heard that our MFJ was clicking. I'm now switching the radio down to, let me say, 7 megahertz, just to check what's happening on 7 megahertz. And you see it is exactly the same, no problem. So that means that it looks like that the MFJ itself is working fine. But let's go ahead a little bit with our testing here. Okay, now we have really a funny setup, because I have put to the output of the tuner here an SWR meter, and I have put here my test SWR setup, so that is 3 to 1 SWR, which I normally use to line SWR bridges. But here for this purpose it is very nice, because we can see if our MFJ works or not. So first of all, you see that we do not have connected our power supply. So that means that under these circumstances, our SWR meter here at the output, which is normally completely mad, but as I said, for these purposes it is nice, because our radio itself has its own SWR bridge and is telling me what the SWR is. So for instance, when I now press here the PTT, you see that my SWR indicator here, can you see it, is, let me do it that way. So you see that it is coming up a little bit, but it is not indicating that it is harmful for our radio, because in that case we would see here a flashing SWR sign. But still, an SWR of 3 to 1 is not very nice. And of course, when we go here to the output of our tuner, you see it, we have exactly 3 to 1. You can read it, and you see that we have our 10 watt output power. So everything is indicated quite right. So having your SWR meter at the output of an antenna tuner will always indicate you the bad SWR of your antenna. But what it will show you as well, if really power goes to the antenna, right? Because our antenna tuner will tune, if you like, the condition what is your radio seeing down to 50 ohm load, whereby the load of your real antenna is not 50 ohm. It is always bad. So you cannot change, if you like, your antenna. So the only thing you do is adapting your radio output via here our tuner to a 50 ohm load, so that the radio itself is seeing a good SWR and will deliver power to our bad antenna. So that is what is really happening. So therefore, once again, we will always see a bad SWR, even when I have switched in, and that is what I'm going to do now. I'm going to connect now my power supply, and you directly see that our MFJ is working. And the point now is that let's see if we can really see it here, because what you will see is that the 3-to-1 SWR will remain, but if it is not adapted right to the radio, then you see that we will not have any output power. And while the MFJ is adapting the impedance, you will see that our power will come up. Hopefully, hope we can reproduce it, but let's try. It will only take a while, a little while, until everything is right. So let's try what we can do here. Look to the power needle. Okay, so it was not very good to see. So you see still our 3-to-1 SWR, and you might have seen that in the beginning our SWR was not perfect, not our SWR or power, and then goes up. So let me go to another frequency. Let's say we go to the 20-meter band. Let's see what we can see here now. Okay, let's see. And here you have seen, that was very nice. So you've seen in the beginning we really had low output power, because the MFJ has not adapted the load to the radio. But now you see we have still our bad SWR, so that is a bad antenna, but we have full output power, and that is what we are looking for. And going here over to our radio, and once again pressing SWR, so you see that our SWR here at the radio is nice, much nicer as it was when we directly connected our bad dummy here to our setup, right? Oops, so yeah, that is right. And now let me go to another frequency, let's say, to the CB band. Let's see what we can see here so far. Do we have the same? Let's see. Okay, let's see what we get here on the meter. And PTT. So that is still good. So it was already adapted quite good. Let me go back to, let's say, a 40-meter band, and let's test it once again here. Yeah, and it was switching, which indicates that everything is fine, and we have a very low SWR at our radio. So yeah, what does that mean? It means that obviously our MFJ is working fine, so we do not have a problem really at our tuner itself, and that is now again that our bias T seems to be having problems, and that is now the next step. We are testing to see if that assumption is right. Okay, and the first what we can test here at our bias T is that we check if we get our DC here over our antenna connection, right? Because you see here we have at the out we have RF and DC, and here on the other side we only have RF in out, right, but no DC. So DC is blocked into the direction of our radio, but towards our MFJ tuner, we have now the DC over our antenna cable, if you like, supplying the MFG with DC and the needed HF signal, of course. So now it is switched off, right? And I've already connected here the 12 volt to our bias T, and now let me switch it in. And okay, so we see that now here at this side of our antenna connector we have our 12 volt, which is feeding our tuner. So that means from the DC perspective everything is fine, but the old man told me that the tuner itself is not working. So there must be a reason for that, and we have already seen that the tuner itself works, so that is not a problem. So let's look a little bit deeper here into this. So, and you see it here on the housing of our MFJ transmitter and DC input, and there is where I have connected here the bias T2, and I have connected my power supply, and I've connected my vector network analyzer, my mini network vector network analyzer. And the analyzer is already telling me whereby the DC is still switched off. It is off, not in. But when I'm looking here, bad camera operation, sorry for that. So what we can see here already is that we have a very, very bad SWR. Look here. So the red one is our SWR, and SWR is at what is it? Approximately 10 or even more worse. So really not good. And the return loss is almost the best is here at 30 megahertz, so there it is getting a little bit better, but in general we can say it is a total mess here. It is not working at all. And now when I'm switching in here our power supply, and you may have heard the MFJ switching, so there is no difference here. We still have a very bad SWR. And now I've taken off here our bias T, and we have connected it directly to the tuner itself without having the tuner in operation. So it is connected through, right? And you see that now our SWR is much better. So the red line here is our SWR, and here at 30 megahertz it is up to 1.5, but it is still over the whole frequency range and all the CW bands. It is really good. Not CW, shortwave bands, of course. It is still fine without any problems, but when I'm putting here, I can simply put it this way, okay, and I put it in here. Let me turn it in. Everything is fine now, and now look how it has changed. So again we have a horrible SWR, and that is more or less a proof that there is a problem here in our bias T. So let's take the bias T apart and let's see what's going on. Okay, and I've taken out our tuner itself, I've taken it out of the game, so we have directly connected it here through our bias T. So the setup is the same, and when we go up here, so you see still that is our problem. So now we're going to take the bias T apart. Okay, and the first thing I have recognized, so here our housing itself, so we have missing screws. So somebody was already in, and when I'm seeing here our contacts here at the switch, it really looks like that somebody already tried to reflow the contacts, obviously, but that was not solving the problem because, and I can tell it right away, what really goes broken when you operate this bias T in a wrong way, you kill this both coils here. And I strongly believe that that is again the case because, you know, if we are feeding in our HF signal and we have this coils here which are going, if you like, to our power supply, we need, of course, dedicated values to be able to block our HF signal into the direction of our power supply. If that is not the case, we are really killing our SWR, and of course we have our DC present at our tuner, but our SWR is bad, and therefore our radio does not work because the SWR bridge in our radio is directly reducing the output power, and that means that of course our MFJ tuner will not work at all. And to prove that, we really have to take it here apart. I need to get here the PCB out, and yeah, therefore we have to solder here all our connections off to be able to lift our board out. Okay, so our PCB is out, and believe me, it is really tricky to get it out. No fun. Anyways, so let's go straight to our inductors here, and let me simply solder them out, because then we are easy able to test the inductors and see if they are still good or not. Okay, so our coils are out. Unfortunately, we cannot find a value on these components. So we only find, it is a number maybe, but yeah, you know, no real marking. But I know from the past that this L1, and you see it is here drawn as one coil, should have 100 microhenry, and normally they put 247 microhenry coils in, and that is the way we should measure those components. So we would like to see simply 47 microhenry. So let's see what the outcome is. Okay, and I've connected it to my Sencore for a good reason, and I will show that in a minute. So first of all, let's test for inductor value. and you see we get 0.2 microhenry, so that means 220 nanohenry, and now it is dropping. And you may say, hey, that could be right, because we do not have a real value here on our components. But what we can do else, we can perform our ringer test. And the ringer test will tell us if there is a short inside. And therefore, let's see. And you see it is only showing 3 rings. And that means our inductor is definitely bad. And because I have here some inductors on stock, we can directly test it. So this here is a replacement type. It is 47 microhenry. So let's test if that is true. And you see it is 49 microhenry, which is the needed value. Now, what happens if I perform the ringer test on this inductor? Let's do that. And you see 32 rings, and that is a good result. So that means that is a proof that our components which we have taken out of our bias T are faulty, and that's the reason why we get the bad SWR, and why in the end our MFJ is not working. But we have as well a schematic, as you may see here, and important for us is our, oops, you can't see it, sorry, is our L1, and you see it is indicated as 100 microhenry. In our circuit, which seems to be a variant, is not an L2, so therefore we can ignore that. But again, we can have again a look here onto our PCB, and we only find here the L1. So there is no other coil here on our PCB. So therefore 100 microhenry for our L1 is the right value. And that means this both means 47 and 47 microhenry, which is approximately 100, would be the right fit. And it is a proof that this both inductors are cooked, and the proof is the low inductance, and additional to that the low ringer indication, which shows that you know, there is a short here on the winding. So that simply means we fit in here our replacement types, and let's go ahead. We have our both new coils in, and now let me put the PCB back here into our housing. Okay, so we are now in our final test configuration. As you can see, the PCB is back in the housing. Everything is connected so far. So we have here our testing radio, of course, on 40 meter band for the moment. And on the other side we have here our LP500, which has to check if the power which is coming from the radio is going through without any problems. And of course here we have connected our dummy load for sure. So what we can do first is switching in our bias T, which then should engage here our MFJ. So let's see. And maybe you have heard the click. So and you see that we are drawing 186 milliamps. So that is showing that the MFG is now working. So our radio itself is, let's see, set to 10 watt output power, right? Which we are driving our MFJ with, and we are starting at 40 meter band. And when I now press the PTT here, you see that the SWR is low, so that means that our radio is seeing the right load resistor, which is of course an impedance of 50 ohm, and you do not see that our SWR bar at our radio is coming up or giving any alarm, so we can be sure that it is fine. And you see that our SWR needle here on our analog meter is fine, no problem, and you see we are getting out our dialed in power. So here from that perspective everything is fine. You see again, or as well, that our power has changed a little bit because obviously our MFJ was adapting a little bit the configuration, and you see that is working. So now let's go over to our LP500 and let's see if the power is getting through. So once again you see the PTT and you see that is quite nice. So our power is getting through. Now let me change to the 14 megahertz 20 meter band. Let's see if we get our power through as well. And you see no problem whatsoever. Let me go up to the CB band, because we know some guys are using it for CB as well, even it is not allowed. But anyways, let's try. And you see we are getting through our power as well by a nice SWR. So no problem whatsoever. Okay, then let's see what happens if we put more power output, let's say 50 watt. So we need to switch here over our meter, and let's see if our SWR stays low. So let's see, and you see 50 watt output power, no SWR bar here, and we get our 50 watt out. And I can see if I go directly here over to the LP500, if we directly check it here, you see we are getting our power through, and everything is working just fine. So that means finally everything is back working. So we fixed the problem here in our bias T, and our new coils which are in are a little bit more powerful, meaning that they are able to take more amps, right? So the old coils were only made for 1 amp, and these coils here are made for 2 amps each. So that gives a little bit more margin, and hopefully that helps not directly blow again the coils. So now I have to reassemble it finally, and then our unit can go back. Well, I really was curious if we can see something here on the old coils, and I'm not sure if you can. You should be able to see it. So the lacquer here is destroyed. So it got over to, I don't know. So you see it is cooked, and that means it is not isolating each winding from the other, and that is a reason that you know, it doesn't work any longer. So you see, normally you have a very good strong lacquer here on the wire, but here in this case it is definitely cooked, and that is the reason. And you see, as deeper we go, so we see more and more here's a problem, and that is because the ringer test was negative, and because that we read the low inductance. Both depends here on our faulty or cooked lacquer on our yeah, here you can see it as well on the wire. So that is the problem. Okay, everything is back together. I still miss these screws. I hope that the owner has them. Anyways, we are definitely here at the end of our video. Hope you learned something, and catch you next time. Bye.